Well, howdy folks at home, it's Mr. Russell and I'm going to show you how to do the Beanium lab. So you'll need this printed out. Most especially, it's going to be nice to have this data table out to fill out numbers as I call them out. So what we'll do is the only things you'll need are your balance, cups, and your beans samples. Okay, so what we're going to do is, let's pretend that this bag is my universe, okay? And these are all the hydrogen atoms in my universe, okay? Now, so each bean is a hydrogen atom, right? Well, they have three different colors. They have, you have the brown bean, the white bean, and the black bean, okay? Or the pinto bean and, yeah, I don't know. But the different types of beans, right? So what I did there is I just kind of mixed them up, just like so. That is the entropy, right? That's actually spreading stuff around. That's the law of the universe that's actually spreading all these molecules around, so we get a nice even distribution. They're just no longer nowhere. There's no clumps. They're just nice and even. Now, what I'll do is I'll take a representative sample just by taking a scoop out. This is kind of what scientists are doing in like an analog. And so I'll spread them all out, and we'll just go ahead and say that that's a representative example. If we were really being a cool scientist, we would do multiple trials, but this first trial was just fine. So you check that out. You can see right there we've got all of our beans. Just like that, you can see all three different types. Now, what I will do is I am going to separate all my different isotopes, right? My different types of beans. So I'm going to separate all the brown isotopes. I'm going to count them out. I will fast forward so you don't have to go through this. Right? Okay, there are 43 brown beans or pinto beans. So that would be beanium isotope number 1. Okay. So brown. And there are, I said there were 42, right? I'm just going to go ahead and write down 42. I hope I said there were 42. So, there they are. Now, on to the next one. Okay. 28. There are 28 white beans, so we'll just say white right here. There are 28. And then now the black beans. There are 45 black beans, so that is good news. So we have to add them all together. Math is hard. So 50, 70, 115, if my math is right. Yeah, 115. So I have them all together. I'm not going to mix them again. That would be a nightmare. And so then you're able to calculate the percent abundance right here. Step 3 says determine the abundance of each isotope using the formula below. So see that formula on there? You just take the number of atoms of each isotope and then divide it by that total number, and then you'll get your percent abundance. Put that same one in column B, and that's just calculated out. Now for number 4, it says using a balance, you're going to measure the total mass of all the atoms of each isotope individually. So what I mean by that is, no, I am not going to take out each little bean and measure each little bean. No, we could not do that in science, right? We would have way too many atoms to look at. So we look at just a group of them instead. We group them together just like this. So what I'll do is I'm going to pour these all out. I should probably go in order. I'll do the brown beans first. So, I don't want the mass of the cup, so I will tear the balance. And then the mass of all of the brown beans together. So the mass of 42 brown beans is going to be 14.87 grams. Good? And then the mass of all the white beans together is going to be 5.95 grams. Oops. And then the mass of all the brown beans, all the black beans together, push the tear button again, is going to be 7.92 grams. Easy enough. Now it says find the typical mass of one atom of each isotope, and see, students will stop there and they'll start and they'll like weigh out each individual one. No, don't do that. Find the typical mass of one isotope of each isotope by dividing the total mass of the number of atoms, column C, divided by the number of atoms in column A. Record the result in column D in your data table. Go ahead and do that. And now multiply the abundance of each isotope by its mass to find the product. And record the result in the last data table. So the product right there. See? So you calculate that. And you'll calculate these three, like so. And if you've been paying attention to the last video on average atomic mass, if you add these three together and put it right there, that is the average mass of your beans. Not the beans individually, but all the beans in the bag. That's the average mass. Because some of them weigh a little bit amount, a tiny amount. Some of them weigh more. Some of them are smaller, some of them are bigger, right? So that's essentially what we're doing. And then you can answer the conclusions and do a little bit of calculations. And then number 7 is a little bit of extra credit that's easy to do. I'll go ahead and research that for you. And that's pretty much it. Have a great day.